This is a university level Calculus 2 exam problem, so it's calculus with integration. If you can do this type of problem, you are well on your way to passing your course, that's for sure. Let's go through this. I give this one a 7 on 10 for difficulty. It's in the long answer category. Let's go through the walkthrough. Find the average value of a function. Here's our function on this interval. Simplify your answer completely. So the first thing is, of course, understanding what the heck are we even talking about. This is just a random function here, just so I can demonstrate from A to B, okay? So if we take the area under, so that's this gray thing, okay? Ignore the orange for right now. If you take all the gray area and you divide it up over the interval from A to B, you're gonna get the orange line. That's how the orange line is generated. It's the average value of the function. It's the average y value of this function, okay? So another way to think about it geometrically is if you took all this gray area and you had to make it into a box. If you had to make it into a box, this is what it would look like. And that's what we're actually finding when we find the average value of a function. So let's go through it. We have this function here. This is the area from A to B. We already saw that, area from A to B. This is the gray zone. And then when you divide it by the length of that interval, so B minus A gives us this distance from A to B here. When you go 1 divided by that, you divide this whole gray area by the length of the interval, and that gives you the height of this orange box. That's what we're getting. So geometrically, that's the picture that you need to understand, or at least I strongly recommend you understand this. Unless this is your last calculus course ever, then all the power to you, just learn the formula. But if you're ever gonna have to use this at all, if you're in engineering or sciences or something like that, you need to understand these concepts. Your understanding builds on these little key moments, right? So you understand this one, that allows you to understand the next one, that allows you to understand the next one, and so on and so forth, right? You may not need to compute these later on, but you have to understand them and how they work. All right, anyways, so let's go through this. So once you see what it is, another thing that helps is once you see what it is, it's extremely easy to compute it, to finish the computation. So all we have to do is we have to integrate our function over our interval. So why do we have 0 to pi over 2 here? Well, they told us that in the exercise, 0 to pi over 2. And then we divide by the length of the interval. It's easy peasy. So now we just have to do these integrals here, which are not super difficult. So you should hopefully be able to do some of these on your own, right? I don't have time to go through all of them, obviously, but there's cosine cubed. You have to use the Pythagorean identity. And then for the other one, cosine squared, you have to use half angle identity. This one, I suggest you memorize. Memorize that the integral of cosine squared x is equal to this here. Okay, that's the last tip for this video. All right, good luck in your exam.